So we get work equals to 332, and then we get finish. Okay, for all the processes, they are F. Okay, 4, 1, 2, 3, 4, 5. Yeah, and we can see it is P0, P1, P2, P3. Oh, sorry. Okay. P4. Oh, sorry. P3. Okay, because I'm familiar. This is first time for me to use this, so I'm not familiar with it. Okay, maybe after a while I will get familiar. Okay, P3 and P4. Okay, so for all the processes, they don't finish, terminate. Okay, let's look at first the need from P0. And we have to find, let's look at the algorithm. We have to find a process that it doesn't finish and its need is smaller or equals to work. So let's find, you can see here, the P0 doesn't satisfy and the P1 satisfy, 1, 2, 2. So first, okay. First, we can see that we suppose night P1 can finish. Sorry. Okay. And we can see P1 can finish and return its allocated resource to the system. Its allocated resource is 200. So we place it here. Then we can see it is 5 now. This is 5. Okay, so when work equals to 532, it will satisfy P3. So the second is P3 will finish. Oh, sorry, we have to write the save sequence. Okay, here is the save sequence. First is P1, then P3. Okay, so P3 finish. Okay, let's look, change the finish. Okay, here P3 finish, we have changed it to we have changed it to, okay, 2. And after, we can see when P3 finish, it will return its allocated resource to the system. Its allocated is 211, so we get 211. So we will get 743. 743. Okay. So here, here, 7, 4, 3. The work will change to 7, 4, 3. After the vector of work change to 7, 4, 3, we can see that it can satisfy all other 3 processes requirement. Okay, so after P1, P3, then we can add anyone, P0, P2, and P4, or P4, P2, P0, anyone. So here with the safe sequence, we can see that I will not write it. So this is the safe sequence. Okay, the safe sequence. So we can see now the system is safe because we find the safe sequence. And from this example, we know that the safe sequence is not unique. It can have many. Okay, so when you do the homework, or do the experiment, or finish the experiment, the safe sequence, you only find one is okay. Okay, so this is the example. And so the system is in a safe state since we find safe sequence. So since the sequence satisfies safety criteria. Okay. And the second, for the banker's algorithm, is resource request algorithm. Resource request algorithm. Let's look at it. Okay. Resource request algorithm. Request vector equals request vector for precise pi. If request ij equals to k, then precise pi wants k instances of resource type rj. First step, if request I smaller or equals to need I, go to step 2. Because the banker's algorithm requires that at the beginning or at the starting point, all the processes must claim the max requirement for the resources. Okay, before execution. So we first must determine if its request is smaller than its need. If it is not, then we say it is it exceeded its maximum claim, or we say it is invalid. Okay, if request I smaller than need I, then we determine if the request I is smaller or equal to available, then go to step 3. If the available vector doesn't satisfy request I, no need for us to do more. Okay, so pretend to allocate. I emphasize that we pretend. That doesn't mean we allocate actually. We just pretend. We pretend to allocate requested resources to pi by modifying the state as follows. First, available equals to available minus request I. Allocation I equals to allocation I plus request I. And the need I equals to need I minus request I. So if we can find the safe sequence, then the resource allocated to pi. If we cannot find the safe sequence, that means the allocation will result the system to unsafe state, then pi must wait, and the old resource allocation state is restored. So let's look at example. The above example supplies that P1 request 102. Using the resource request algorithm to determine if the request can be granted. First, we must see, because P1 request 102, so we see it is smaller than its need. Okay, P1, its need is 122. 2, its request now at present is 102, so it is smaller than its required need, so it's valid. Its request is valid. And the second was say after its request 102 is smaller than available. We can see now available is 332, so it's valid. Okay, then we pretend that we allocate the request, the resource to process P1, then the system state change to a new state. Okay, so we get this one. Here you can see the need change to here only, of course, only P1, and available change to this one. Okay, then at this we find, let us find the safe sequence again to see whether we can find the safe state. Also the same, the work equals to available 130, and the finish, work equals to 230, and finish equals to false for P0, P1, P2, P3, and P4. Okay, so let's find the need. Okay, first P0, it of course it is larger than work, but for P1 it's okay, it's smaller than work. So we suppose that the safe sequence is here. We assume that we first allocate the resource to the P1, then the P1 can finish its execution and return its allocated resources to the system. So here, then here, and return its resources to the system. So the system resource change to 532. Okay, 532. Okay, and okay. Okay, after change to 532, can say it can satisfy P3's requirement. Okay, so we assume that we allocate the requirement to satisfy the requirement of P3, and the P3 can finish its execution and return its allocated resources to the system. Then the work will change to 743. Okay, first here, the second is P3, then the allocation, So you can see the work will change to, okay, 7, 4, 3. So after the work changed to 7, 4, 3, it will satisfy all the requirements of all the other requirements of P0 and P2 and P4. So after this, you can write P0, P2, P4, or change them any sequence. Okay, so we get safe sequence. Okay, here we get safe sequence. Okay, it's the same as the above one. Okay, so here it's the same as the above one. So because we can get safe sequence, so we can satisfy the requirement of the precise P1 and allocate the results to the precise P1 actually, and the system will change to less state. Okay, so so executing safety algorithm shows that sequence P1, P3, P4, P0, P2, of course, also P1, P3, P0, P2, P4 satisfy safety requirement. So when the system is in the above state, the request for 330 by P4 cannot be granted. So you can see because P4 332, okay, though its requirement is smaller than its need, but it's larger than available. And the request for 030 by P0 cannot be granted. So let's see. Though its requirement is smaller than this one, than its need, and it's also smaller than available, but assume that we satisfy, then the available will change to 200. Okay, this one change to 200, and we can see it cannot satisfy anyone's requirement. So the system will change to unsafe state. So we cannot satisfy P0. Okay, cannot be